Hello, can you hear me?
Yes, I can. Good evening.
All right, good evening, everyone. Please verify that you can see my screen. Please verify that you can see my screen. Okay, so I'm having a bit of.
Yeah, it's showing that you're sharing, but I can't see anything.
Okay, let me try. All right, then. I believe you can see my screen now.
Yes, yes, I can.
Okay, so yesterday we looked at Seaborn and how to plot some basic charts with the Seaborn library. And for today, we are going to be looking at the Altair library and how we can use it to plot some charts as well. For today's class, we're just going to take a look at how to interact with the library, how the whole library works, how you can use it to plot some of the popular charts that we know about, and what advantage it basically gives over the other libraries. Okay, so from here you can see that Altair is a declarative visualization library for Python, and the core goal is that it will help you to spend less time writing code and more time exploring your data. So it's like a declarative kind of visualization library. You just basically tell it what you want it to do, and then it will get it done. You don't have to customize too much. You just have to declare using the methods and attributes that are available within the library. So some of the things, first will be importing the necessary libraries that we need. We import pandas because Altair works really well with pandas data frame. And if you're working in VS Code, I specified some things here. You need to specify renderers so you can see your charts in the notebook. Is anyone working with VS Code here? Or are we all using Jupyter Lab and Google Colab? So what environments are we working with, please? You can put it in the chat box. Let me see. So I know that we are all on the same page. Okay, Jupyter Lab, Google Colab. All right. So I take it that there's nobody that is working from VS Code for now.
Oh,
Okay,
bien
please
sûr,
mute
moi,
yourself.
moi aussi.
Please, whoever that is, please mute yourself. Please check that you are muted. Okay, so in that case, if we're all working from Google Colab, these are just some of the basic transformations of this. So also, this library, right, has some kind of, it will output an error if we try to work with data sets that have more than 5,000 rows, because it has a limit on those 5,000 rows, right? Whenever we're trying to plot certain charts and all that. So what I did here was I basically disabled the max rows method, right? The max rows attribute that is defined with the data transformers, so that we'll be able to plot as many rows as we want to. So this is something you need to include when you're trying this out. And then we include this renderer so that we'll be able to see our charts in Google Colab. Now, when you're interacting with, the first point of interaction with Altair is the chat object. So I'm going to take us to the documentation right now. and this is the chat object, right? And this is like the fundamental object within this library that allows us to utilize the rest of the attributes and methods that are in here to plot our graphs. So we use this for depending on the graph we want to plot, we have this mark point method that allows us, depending on the graph we want to plot, right? So it can vary. We have mark line, we have mark point, we have a number of them. And so first of all, this chart accepts our data frame. That's why I told us initially in the beginning that it utilizes and it worked very well with Panda's data frame. And then from there, you can now call the particular method you want to use to work with whatever chart you want to work with. So we'll see all of that as we go through. So like I said, we have mark bar, we have mark points and all the rest. So I have uploaded my data set in here, clean sales data CSV. And I'll go ahead and read this. I'll probably just clear my runtime. So first we have to import everything we need. And then we go ahead and read our data set in. So the data set we have is Adidas sales data set. So let's inspect it so we know what we're working with. So this is what we're working with. We have, it's basically a sales data set on the various products that Adidas offers, and from various retailers, various regions, basically a data set of all the things that, all the products that we sold and the various metadata on those sales, right? So we have the retailer ID, voice, date, region, all of these columns. So we are going to do some like very basic transformations. I included it here because I didn't want that to be the focus of our class today, but I'll just briefly explain. I'm trying to rename the column, as you can see, for consistency's sake. I want to make all of this to be lowercase, and then I want to replace the white space with an underscore. So that's what I'm doing here. Renaming the columns with the column parameter, right? And then I'm passing in this, which basically generates the column and then the key value being the column from here, and the key being the column from here, right? And the value from here being the transformed column name. So that's what's happening here. So when I run this, and then in place equals to true, basically is my way of saying that the transformation should take place on current data frame. So when I do the df.head again, we should see that our column names have been transformed, right? So it's a good idea to inspect our data frame just to see what our objects are like, what our different columns are like, the data type, the null count, and all of that. But we won't be doing a lot of transformations today. We're just going to be focused on trying to understand the alter library and using it for visualization. Okay. Okay, so someone is asking if I can share the data set. Yes, I'll share the data set after the class. All right, so from here, we have a look at our data types, retailers, objects. We basically have almost all objects, retailer ID, integers, and units sold. Our date is an object, but we don't want that, right? we want our date to be a date-time object. So this is some transformation that's happening here. We want to see, I prepared a list of questions to guide this session. So basically, we're going to be trying to answer some of those questions in this session. So by producing some of the charts that we'll be producing, we'll be able to answer some of those questions. So men's street footwear sales by month for 2021. So our data set, let's inspect our data set and see what we have, right? Let's see the dates column. So we see a range of dates. We see 2020, we see 2021. So first thing we want to do, we want to try out, we already know that this is an object. So we want to do a conversion. Let's make this a date-time object. And the way to do that is to call the pandas function to date-time and pass in that column. Now we've been able to transform this. So let's set it to the initial date column. So let's quickly do that. Now we can go ahead and we want to inspect men's street footwear sales by month for 2021. So what we need to do here is we need to pull out the month, we need to pull out the year as well. And if we take a look at this, I don't want to repeat what has already been done here. So I'm just going to explain what's going on here. So we are looking out for men's street footwear. So let's take a look at the products within this. I just want us to see the value count. Let's see the range of products that are in here. Okay, so we see men's street footwear. We see all the different products that we have within our data set, right? And so we want to specifically do this strictly for men's street footwear sales. So we're going to, that's what is happening here. It's filtering our data frame and picking out only the rows where the product is men's street footwear. That's what's happening here. And after that, we converted our date column to a date-time object, which I showed you up here. And then if let's pull this out and let's test this just so that we're all in the clear. So you see that this matches what we have here, right? So that's one way to confirm. Then moving on, we see the months. We want to define a month column. And typically, right, when we reference the month parameter, the month attribute rather, from the date time objects that we have, it's going to give us the month number. But we don't want the month number. We want the abbreviated month name. So like January should be Jan, February, March, all of that. So that's what's happening here, right? And then we extract out the year and we extract out the day. And then we are able to have all of this. And then we are able to have, we extract out the day as well, pull out the day from the date time objects, right? Pull out the year from the date time object as well. And now what is happening here is that I'm filtering the data frame for only the years that match 2021, okay? I'm going to be filtering the data frame for only 2021. So let's see what the shape of this data frame would be. Oh, sorry. That should be. Okay. So I've been explaining this, but we haven't run it yet. Okay, so now there's no need for all of this. If we just try to compare the shape of the initial data sets against the new data frame that we have created, yeah, we can see now that we've been able to filter out some rows and we've gotten an appropriate shape that we want to work with. All right, so now we're going to be moving on to plotting our charts, right? And we want to plot a heat map. That's what we want to use. That's the chart we want to use for this. We're going to be using a heat map. And so if we go to our documentation, the Altair documentation, right? And let's go to our APIs. So we're going to be going back and forth with documentation because I want to show you how, as a beginner, you should approach this, right? Going back and forth with the documentation until you figure out what you want to do. Okay, so for this, it offers us some map objects. So let's just search for map. In this case, let's see the list of map objects that we have. Sorry. Okay, give me a minute, please. Let me figure this out. So these are the list of the plots that we can access from our chart object. So we have the mark arc, which we can use to plot a pie chart or a donut chart. We have the mark area, which we can use to plot an area chart. We have the mark bar, which we can use to plot a bar chart. We have mark box plots, which we can use to plot a box plot, right? We have the mark circle, which can also use to plot arcs and bubble charts. We have the mark error band, we have the mark error bar, we have mark geoshape, mark image, mark line, mark points, which I'm going to demonstrate to you to show you how this typically works. We have the mark rect, which is what we're going to use for our heat map. Then we have the macro and a couple other things that allow us to lay on top of our charts and to customize it to the way we want to do it. So we're going to call the mark. Remember, I said that the very first point. Oh, wow. Okay, I'm having a bit of, I think I have to stop sharing and rejoin. Not sure what's going on. Okay. All right, so our first object of interaction within our alter library is the chat, right? That's what I said. And then the first thing that you pass in here is your data set. In this case, it's going to be data set 2021, right? And then we want to work with the markrect object, right? The markrect method rather. And so now that we have specified our data set and we've called the method that we want to use to plot our graph, the next thing that we need to do is to do some encodings. So, but before we go ahead with encodings, I'm just going to quickly show you how this chart works. So now let's say I specify a data frame object, right? And I use mark points, right? Hope I got that right. I'm always mark dots or mark points. Yeah. So let me quickly check the documentation. Yes, mark points. Okay. So if I run this, right, I don't do any encoding or anything. Let's see what happens. So it's after it runs, it takes a bit of time to show up. But bear with me. Maybe we'll have to run it again. Okay. So I'll go back to try mark points. All right. So now we have this singular dot here is all of our data set. Our data set has about 9,648 rows. Everything, all the data points layered on top of the other, right? Layered on top of each other. So that's what we have here. But we don't want, this doesn't make any sense to us, right? So if we want to actually plot, we want to plot this against a certain position, against a certain color, against a certain size. We want axis for our data set. So that is when encoding comes in, right? With encoding, we can start with it. We can have a one-dimensional chart, and then we by the axis that we want it to be. It can be our x-axis, and we can say, okay, from our data set, what axis do we want to go with? Let's use a category. Let's look for something that's an object, right? Let's use maybe a retailer. So we put that in there, retailer. And what do we have? We still have everything that corresponds. We have an x-axis right now, but yet we still have data points layered on top of the other. So it still doesn't make sense. So basically, an encoding is like mapping certain encoders within that are specified by Alted to columns within our data sets, right? So in this case, we are mapping our x-axis to retailer. We want to map something else. Let's say we want to map our y-axis to, let's say, because this is a sales data set, so let's map it to total sales, right? This total sales. So let's go ahead and map it to total sales. So we can see now the various data points within our data set as they. So for each retailer, right, we have all the sales, because we have a column called total sales, all the total sales. So this matches if you check within our data set, you will see the data points that rhymes with Amazon and had a total sale of about 0, right? And then, so all of the data points within our data set is being plotted via this mark point. So this, I just wanted to show you how it typically works. You have encoders that you map to columns within your data set, right? So another way that we can specify the x-axis within this encoder is by using the alt X object, right? And then we specify, okay, that we want it to be retailer. Specify the alt Y object and specify that we want it to be total sales. And then we run this. So it gives us the same thing, right? So those are two ways that we can work with. I focused on the position of our the position, right, of how we want our data to be plotted. That's the X and the Y axis. So moving on, let's go ahead and plot our mark rates. Come to the documentation and we see what specifications we need to make from the documentation. So like I said, mark rates helps us to plot a heat map. So we go ahead and pick any of the examples of a heat map specified here. And then, so you have the method syntax here, and then you also have the attribute syntax here as well. So whichever one works for you, right, you go ahead and use it. So for our case, we're just going to specify our x-axis and specify our y-axis. Remember we said that, I'm going to go ahead and delete this so it doesn't obstruct us. Okay. So remember that we said that we want to see, what was our goal initially? We want to see men's street footwear sales by month for 2021. So we have a month column in our data set. We've filtered our data set for 2021. And now we simply want to see, okay, if we put month on the y-axis and we put the sales, right? We put the day on the x-axis, then we use color to filter it. What is it going to look like? Let's go ahead and do that and see what we have. So I run this again. This doesn't make any sense. So what do we need to do? We need to specify that the color needs to change when it gets to the max total cells, right? So Altair allows us, provides us with aggregates that we can apply within our encoding. So I can apply, in the example like I showed you, and I can apply like some aggregates within the encoding, right? I can either use sum, I can use mean, I can use maximum, I can use median, right? So all of those aggregates are available. Okay, so I want our data set to be on this other axis, right? So something is happening here. It's not giving us the heat map that we want. One thing you need to look out for is that with Altair, you need to specify what type of data it is. Otherwise, it's going to treat it like numerical data. So it sees this and thinks that, oh, this is numerical data, whereas it should be treating it as ordinal data or categorical data. So we're just going to specify this here. And then we have what we're looking for. But even we want to go even further, we want to specify, we want to sort the months by, because the way it's arranged does not give us a good view. Remember, the concept is data storytelling. You want to guide your users' eyes to see stuff. You don't just want to show them. So how can we sort this so that it starts from in the correct order, basically? So we're going to use the sort function, right? At this point, that's why we have two options. We have the option, like I said, we have the option of specifying the y-axis or the x-axis directly within our encoding function, specifying these parameters directly within this encode function. Or we can call the method directly from the alt library, right? So we're going to use that. That particular approach allows us to customize our x-axis easily. We can specify the titles, we can specify some customizations for the axis. So that is what we are going to do. We are going to replace this with alt.y, and we're going to go ahead and specify the month and the fact that it's an ordinal variable. Then we're going to go ahead here and specify this. We'll be working with the D. Okay. All right, so now let's go ahead and include what we need for our sorting. So we're going to call a function, call a method within here that allows us to sort field. And we want to sort by the day, right? Sorry, we want to sort by the month. That's what we're doing. We're sorting by the month number. We can't sort by April because, as a matter of fact, this is already sort of, okay, it's really not September. If it was sorted, I thought this was like sorted based on like alphabetical order of month. But my point is, if this was sorted, April would even be starting here. December would be like among the last row. So, but this won't make any sense. We want to sort by the month number. That's why we had to include the month number somewhere here, right? So we want to be able to sort by the month number, and that's what we're going to do now. So now with this, we're able to look at our heat map and okay, this looks a lot better than it was initially. So we've come from a place where it wasn't making a lot of sense to where it's looking a lot better. So now we can see that there's really what's really the pattern to our data set. We can spot some of the months where there was a lot of high sales. So we see that in July, day 16, we had quite a huge sale. And interestingly, within around the same dates, we had huge sales. It's something that can make us look deeper into our data sets, but we're going to pause on that for now and move on to the next question. Okay, so the next question within our data is which region generates the most sales? Some other customization that you might want to do, you might want to specify the title. If you're not comfortable with the day, the month, you feel free to like specify the title within this. Yeah, so that's some of the things that we can do with when we use this instead of explicitly specifying X and Y. So moving on, so we can cover some other charts before this ends. Which region generates the most sales? So we can first of all run this. This is basically grouping our data sets by region and summing up the total sales within that. So if we do that right, go ahead and run this. And let's go ahead and inspect it and see what we have in here. So looking at this, it looks like the West has the highest. It's kind of like a bit difficult to tell. I mean, we can sort values. Okay, so the Midwest has the most. Am I saying that correct? The Midwest has the most, and then the South, and then the Southeast, Northeast. Either ways, let's look at it from our let's plot a pie chart rather. Let's plot a pie chart so that we can see how that looks. Now, to plot a pie chart, we are going to be using the mark arc, right? So if we go back here, we see the mark arc that allows us to plot a pie chart. And then we go ahead and we can do a search just to see the documentation and what it says. Then you have a list of charts that you can plot, the donut charts, the pie charts, and whichever one you want to do. So let's go ahead and plot this. We specify we're using the region cells. Now, in this case, we are not going to be having the X and the Y axis. Rather, we are going to be having theta, and then we're going to be specifying the color, which is like the various labels, right? That's like how we're basically telling it, okay, map colors to this column, right? Check the number of unique values within this column and map colors to that. So that's what we're going to be doing. So we're going to go ahead and specify what we have here. Okay, what did we do wrong? Our Peter has no schema called column. Okay. So we didn't close in. All right. So if we don't want to specify like let's say we don't want to specify these legends, right? We don't want to specify this. We can go ahead and set it to none. For that, let me visit the documentation to see, just to confirm. So like you see here from this, you can set this to none. So that's exactly what we're going to do here. And also, so there are two ways to get this done. We can either call the legend on property, or we can specify it within the color object. So now, let's go ahead and like add labels to our chart. We're going to copy this and paste it here. And then what is going to happen is that we are going to form a base. And then so in Altair, you can concatenate like charts, right? You can join one or more charts together. So that's what we're going to do. So basically, we're going to form a base which other charts that we are going to develop from this are going to inherit. So we're going to take away this because this is specifying a particular chart already, but we don't want to specify a chart. We just want to like specify some configurations that we will later inherit and utilize. So we'll go ahead and specify the region, we'll go ahead and specify the color, we'll go ahead and specify that we don't want like any legend. And then we can also go ahead, copy this and paste, and then go ahead and make our pie chart. So we make a pie chart off of the base. So there's no need for us to explicitly call chart anymore. We're just going to be creating it as a base from this. And then all of the things that we specified previously, we don't need to specify them anymore. So we're going to take this off. And we can just specify the outer radius. Let's make that 120, right? And then let's go ahead and create the text. So the text, which if we go to the documentation again, you're going to see at some point it showed us this mark text, which allows us to set the chat mark to text, right? It allows us to specify some text that we want to add to our chat. So let's go ahead and do that. So let's specify our radius here. Let's make it, let's see, 145. And then let's go ahead and encode the specific text that we're looking for. Specify map text to the column that we want to use as our text. So which is basically region, because that's the data we're filling. So let's run this. Okay, sorry, one last bit. Remember we said concatenation. So let's go ahead and concatenate this and then run it. So now we have our pie chart with all of the labels specified. Another thing that we can do is to specify the inner radius to create a donut, right? So we don't want to use a pie chart. We think a pie chart is rather boring and we want to use a donut. So we can go ahead. I'm just going to copy what we have here. And the only difference is going to be that we're going to specify an inner radius, right? So we're going to go ahead and specify our mark arc here. Specify an inner radius. Let's see, let's keep our inner radius at 70. And then our encoding looks fine. We have our region, we have color as region as well. So let's go ahead and run that and see what we have. All right, so we see that you can tweak this to whatever number you want. Whatever works for you. So this is what we have. We've been able to create a pie chart. We've also been able to create a donut. So you can look to the documentation to see other things that you can do. So we have donuts, we have Pac-Man charts. These are some other, yeah. So I'm not sure the use case for this, but I mean, data visualization is a science as well as an art. So probably you can have a use case for this, and then you can do this. So there are a couple of other visualizations and other things that we can pull through with our MAC-ACK method. So let's go ahead and see the next question. How does operating margin differ between product categories? And we're going to answer this question with a box plot. How does operating margin differ between product categories? Example, footwear and apparel. So we might need to, let's remind ourselves of our data set a little bit and then see where we go from here. So we have operating, okay. So we have operating margin, and then we have different product categories, men's street footwear, men's, all of that. And now we can use other charts to answer this question, but we're going to stick to using the box plots to see what we can do with this, right? So it's still going to take the same approach, right? Specify our data frame, and then go ahead and use the MAC. So for the data on our x-axis, we want to see operating margin differ between product categories. So let's start out with our operating margin. And then for our categories, we'll use our product. Let's run this initially and see what this gives us. So we can go ahead and customize this and use maybe some colors, right, to differentiate between the different products. So one way we can do that is just to specify the color. I'm back to using just the parameters, right? So I'm just going to go ahead and specify that it should be product. Okay, so this is what we have. This is what it looks like, but I very much prefer it without the coloring. So let's keep it that way. We can also decide that we want to specify some colors here as well. That's also possible. Customization, the way that you would want it to happen is possible. You just need to check the documentation, check resources online, and just ask the necessary questions that you need to ask to arrive at the charts that you want to. So this is what we have. And we see our box plots, right? We see the men's apparel, we see the men's athletic footwear, and we see that we have a couple of outliers here for the men's apparel, right? And then we have, for our operating margin, we have like a lot of outlier here. We have not so much here, not so much here, not a lot here. So this works when we want to compare like the distribution between the different products. So let's go ahead and see what we have here. So for this, we have, this is me specifying the different retailer groups. I just want us, this thing make a lot of sense because there's a lot of data clustered here and there's no like really clear pattern to it. So, but I just want to demonstrate how we can use this to plot like a scatter plot, right? So we use the very first method that we use, which is mark points, right? Like I said, you can specify the color that you want to utilize. But it's not really necessary here because we're already specifying colors based on product. So go ahead and run that, and this is what we have. First, this can be merged into one, right? But I chose to do this. First of all, filtering for retailer matching Foot Locker, any retailer that is Foot Locker. Then I go ahead and filter for Northeast, and then that's the data set that we are plotting here to see if, okay, there would be like any correlation between the price per unit and the total sales. So, and this is typically how you use like a scatter plot, right? As we get deeper into like end-to-end data analysis and visualization, we are going to like walk through where we formulate the questions ourselves. We're going to come up with very reasonable and meaningful ways to utilize our scatter plot and see relationships between our variables. Then which marketing channels are most effective at driving sales in each region? So this is the last one we'll take before we end our class today. Which marketing channels are most effective at driving sales in each region? So we can take a look at our data set and try to see the marketing channels. Sorry, I have such short-term memory, so I have to check the data sets consistently. So which marketing channels are most effective? Marketing channels. We're looking for our marketing channels. We've added some data sets in here. Sales method, right? So yeah, basically marketing channels in this case is like sales method. So in-store, the various stores. So let's take a look at, let's just see the count value of that. So we see the various value counts. Now let's go ahead and plot our, we want to do, this is just a value count, right? But let's say that we want to understand like how it contributes to total sales. What we would do would be to group this. We would group our data sets by the sales method. And then we will go ahead and select the sales column and perform an aggregation, which is like the sum. That's what we want to do. This is just a count of entries, but this is like the actual sum that we want to work with. So in this case now, we can remember we need to pass in a data frame object. So and we need to specify the columns. So but this is like the index and this is like the value. So what we can do here is just reset the index. And okay, now let's go ahead and set this to a data frame. Oh wow. Okay, just waiting for this to, okay. So now let's go ahead and set this to a variable, right? So let's just say sales, let's say method df or something. So I have to run this again from the start. So I'll just I can't, the data set has like been removed from the session. So I'm just going to show you from the documentation what method you can use. And then perhaps as an exercise, you can try that. And then I will be in the Slack channel to provide feedback if you need. So we're just going to take a look at the mark bar. So we have bar charts with labels, bar charts with line anatomy, bar charts with range. As a matter of fact, this mark bar can also be used to plot histograms because Alter doesn't specify like which method to use for histogram. The bar covers everything. So let's take a look at this bar. And then what you see here is see your data set here, see that only one axis was specified, and that's what we have here. But then in our case, we want to specify like two axes. And then what's happening here is like an aggregation is happening here where you have the sum. So in our case, we explicitly like got the sum of total cells. Let me go back here. We explicitly got the sum of total cells from our data sets, right? So there would be no need to like specify that sum here. But if we did not want to do that, we could have gone ahead and used the initial data frame and specified the sum. So this is just specifying like the data type and then plotting this. You can, yes, another thing I didn't mention is that you can specify the properties so that it will now like shape your axis, right? So if you want to widen your axis, you can specify the width, you can specify the height. So that's then for, like I said, for histogram, we can have the bin here. So we specify the bin method that now allows it to be plotted, categorizes our data as bins and then plots it as a histogram, right? And then for the stacked bar chart, we need to specify the color, right? So this is what you need to do. And then in our case, we're looking at, let me quickly confirm the question. So what marketing channels are most effective at driving sales in each region? So we could have decided to see, okay, marketing channels. So yeah, we did this the other way around, but let's go with that, right? So one thing we could do is like, let's see how the different regions contribute to like the various marketing channels, to the sales from the various marketing channels. So in that case, we would specify to our color the regions, right? So, but if we wanted to do it the other way, right? If we wanted to get, okay, how do like, for every region, how do the marketing channels contribute? What we would typically do is our x-axis here would be, sorry, let's get back here. Our x-axis is going to be the regions, right? And then the y-axis is going to be like, it's going to be the total sales. And then our color, which will cause it to be stacked, which will like segment our different, based on the category we want, which in this case, the category we're looking at is marketing channels, basically sales method. So that is what we'll specify as our color. So, and I think you guys should go ahead and try this and let me know how it goes. So, I apologize, we've stayed longer than we should have, but I wanted to cover the basics of plotting the most popular charts with Altair. In our next class, we're going to look at like interactions. This one other feature of Altair is that it offers like interactive visualizations. So we're going to take a look at that. And yes, please, Nathaniel, what's your question?
Yes, thank you so much. So I was going to ask, are we getting the slides and the materials up?
Can you get the notebook?
Yes.
You can. I'll make it available to you like by tomorrow morning. I'll just clean some things up and make it available to you. Is that fine?
Oh, okay, thank you.
Okay.
Yes, it is.
All right. So, all right. Any other questions? Okay. Okay. In the absence of any other questions, thank you very much. I can see like 10 people stayed to the end of the call. I don't know if it's 10 that joined, but yeah, thank you very much, everyone. Until our next session.